Hi, everyone. Welcome to this morning's webinar. We appreciate you attending. Today, we're going to be talking about the Faro Focus as well as Geomagic Design X and how it was used in the Schooner Zodiac case. This is a case study currently existing on 3dsystems.com, and we're lucky enough to have Christian Stark and Ross Nairn, both guys who worked on this project. They're going to walk you through their process between scanning the boat as well as some of the modeling that was done afterwards. Just to let you know that at the conclusion of the webinar, we'll do a Q&A. The Q&A, you can use a questions box that is located in your management panel down on the side, so feel free to use that to fill in your questions, and we will answer them at the end. We also have a couple specialists from 3D Systems to talk more about geomagic design, and someone from Faro as well, Zach Flynn, sales engineer for Faro, who could talk more about that if you're interested in asking questions about the hardware. So without further ado, I'm going to go ahead and turn this over to Christian Stark.
Yeah, good morning. My name is Christian Stark. I am a volunteer crew member on the Schooner Zodiac. I'm also a mechanical engineer. I got a master's in mechanical engineering like 20 years ago in Germany. So 20 years ago, I spent a lot of time on CAD and CAM systems, but then ended up working in office productivity software in the United States for the last 20 years. And just for this project on the Zodiac, I got back into playing with this CAD engineering software. The history of this boat, it's 90 years old. It was built 1924 in Goose Bay, Maine. It was initially built for the Johnson & Johnson family as a private vessel, as a private yacht. And it's about 127 foot long on deck, 160 foot sparred. Today, it's used as a charter and sail training vessel. So if you ever want to go on a tall ship trip, call us up, and we would love to have you on board. Anyway, the boat, after the Johnson family sold it, ended up being used as a pilot schooner for 40 years in San Francisco Bay. And a pilot boat basically brings out pilots to big freighters outside the Golden Gate Bridge, drops them off and then they bring the boats, the big freighters, into the bay, and vice versa on the way out. Now, during this process, the boats basically always will dock on the big freighter on port, which is the left side on the boat. And when it's big waves and big wind, that can be very violent, so they could crash on it. So when the boat was restored in the 70s and 80s, there was some substantial structural damage on the port side, which was repaired. However, the current owner never knew to what degree the hull on port is different to the hull on starboard. Now, when we're sailing the boat, we know that there's a slight difference in sailing behavior on port or starboard tack. However, we never knew exactly to what extent. Now, when I was on the boat 2 years ago, I talked a little bit more about it and learned that there is no blueprint for the boat. The shipyard burned down, and the one set of plans which was stored there burned with the boatyard. And unfortunately, a few years later, the naval architect William Hand's office, where the second set of prints was, burned down as well. So now here's his boat, and it's beautiful, but there's no blueprints. Okay, so basically, when I was on a trip, as things happen, Ross Nairn was on this trip, and he's a 3D scan engineer, and we started talking about how can we get some blueprints of this boat. And so this is how all this got started. Ross came out, did the scan, and he'll talk about it and in a couple of minutes. And then after he talks you through how we scanned the boat, he will also explain all the detail, the technicalities with using the Faro scanner, and then I will go talk about the actual modeling in Geomagic Design X. What you see here is when we brought the boat into the dry dock in Seattle, because the boat has to be out of the water, or otherwise you're not going to be able to actually conduct the scan. And so here you now see the boat coming out of the water, and this is kind of a time-lapse video I shot. The whole process took about 2 hours to get the boat out of the water. Now at this point, I want to go to turn it over to Ross, who's going to go talk to you about the scan process.
Thanks, Christian. Let me just get my screen ready here. So, as Christian described, I was a passenger on a cruise on the schooner Zodiac, and as conversations go, I learned that there was no original data for the ship, and got talking to Christian, a fellow engineer on board, and I said, hey, the technology exists, we can do this. And what's kind of funny is what they eventually want is kind of the original drawings of the ship made back, which are a series of lines. And of course, 3D scanning has evolved. There's now ways of getting millions and millions of points, ways of generating surfaces, but what they wanted was to dial that all back down into lines. And so we're kind of using some high-tech equipment, let's say, to serve an old-school purpose, but it really did fit the bill quite well. So I went out in March last year. My name's Ross Nairn, by the way, and I'm a mechanical engineer involved in the metrology field. The equipment was provided by a company called TSC in Toronto, and we brought out a FaroFocus unit to do the scanning. In sailing, probably the most important factor is the weather. You want nice winds to be able to get where you're going. Everybody likes a nice sunny day. Well, in Seattle, when you're scanning outdoors, the most important factor is the weather. It rains a lot in Seattle. Sorry, people from Seattle, but there's apparently a 60% chance of rain any given day in March. So it really was kind of a race against the clock to try to get the work done. So here you can see the FaroFocus unit that we used. It's a fairly small device, kind of briefcase sized, a little bit smaller. Stands on a tripod and very portable, very lightweight. It's easy to travel with it, as well as getting into awkward spots, which we did manage to get into a few of those. So before the ship went into dry dock, we had the opportunity to take a few scans while it was still in the water. And the reason for this was we wanted to establish where the actual water line of the boat was. And so we did a series of scans, some at the bow of the boat, as you can see here. And you would capture the bow, and then, of course, where the water meets the surface, you wouldn't get anything through the water, but you get an absence of data. And so this would be able to be used to establish where the boat was actually sitting, because once it went into dry dock, it's kind of an artificial condition. Level with respect to gravity isn't really true anymore for how the boat normally floats. You can see here, sitting on the tripod, the focus as well. There's a small color interface for doing settings, file management, stuff like that, and starting the scans. It's really easy to use. One button push and starts the scanner in motion. And depending on how long or how much resolution you want on that scan is depending on the amount of time that it takes. Here at the rear of the boat, we did another couple of scans, again, to establish water lines, so you'd get data at the front and the back to piece it all together. And nice thing about the FaroFocus, it's all battery powered. There's no cords, no laptop to hook up. You can just plunk it down where you need to take a scan, hit the start button, and away you go. So here you can see a picture of the dry dock, as you kind of saw in Christian's time lapse. And so essentially, if you're not familiar with dry docks, in this particular case, the boat will maneuver into it when it's sunken, basically, positioned into place, and then they pump the water out of the side walls that you see there. And by pumping out the water, the buoyancy changes, the dry dock lifts up, and of course anything on it is also lifted up as well. You'll notice in the bottom left-hand corner there's a stairway which goes down into the water. Of course, when the dry dock's lifted up, that's the way to get from the bottom of the dry dock to the top platform that you see here. And here's the schooner Zodiac backing into the dry dock. It's no small feat to do this. You can imagine this is a 90-year-old sailing vessel, although now has a motor in it, but there's no bow thrusters, and you're trying to reverse in a 160-foot object into a relatively tight parking spot. It's quite a feat to see. So here they are in the dry dock, just securing the lines, making sure that things are positioned right. There was actually a scuba diver that went down to make sure that it was aligned properly so that it would rest on the proper supports, because obviously normally it's held up by water, and it's a bit of an artificial condition once it's going into dry dock. And so now that the water has been pumped out of the dry dock holds, here's the schooner Zodiac sitting on its keel and a couple of side supports. You'll notice there's a couple of kind of 4x4 braces on either side of the Zodiac, which is there kind of just in case should anything happen. Down the bottom right, you see Christian walking around in the remaining water that's still leaving the area, kind of checking things out. A couple other interesting things you'll notice down near the rudder and the propeller, there's a bunch of barnacles attached to the bottom of the boat. Of course, when we're doing these scans, we want a clean data set as clean as possible, and so what the crew did is they power washed off the bottom of the boat to get rid of all those barnacles and whatnot so that we'd get a nice clean image of the boat. There's no real need to measure barnacles in this case. We kind of had to race against time. The Zodiac only had the dry dock for a certain amount of time, and the maintenance crew wanted to get busy going at it. So we had a kind of a small window to get the scans done. And of course, with Seattle weather, it was always threatening rain, so you always kind of were under the gun to make sure that things got done as quick as possible. So the first scan was done rear of the boat in the area of the propeller. This area was done first because maintenance guys wanted to take the propeller off, and so I wanted to get those scans done first to capture that kind of as-is, properly installed condition as complete as possible. What we did in order to facilitate the alignment of the various scans that needed to happen, I should back up a step. In order to scan the boat, multiple scans are required, basically working your way all the way around, kind of finding all the line of sight limitations that need to get resolved in order to get as complete coverage as possible. And so to facilitate that, what we did is we put a bunch of spheres or alignment objects on and around the Zodiac and the dry dock walls. You can see them circled there in yellow. There's a few of them. They're kind of all around. Generally, 3 would be the absolute bare minimum in terms of registering 2 scans together, but of course you like more. We used a total of 12 spheres. And in some cases, we kind of leapfrog some ahead if they weren't being used anymore to kind of multiply that out a little bit. And so those spheres are very helpful for registering the scans, which we did in the Faro Scene software once all the data collection was all done. So this is an image from that Faro Scene software of one particular scan from the rear of the boat. You can see, again, I've highlighted the spheres in the data, which the software will automatically recognize and use for alignment purposes. The data here is shown in black and white. We did actually do color scans, which gives an extra kind of layer of information that's available and adds realism to the visualization of the data. Here's another shot of us scanning this. We're at the bow of the boat. Again, you can see spheres on either side of the boat. And this is really important in order to link the port and starboard sides of the data set together, because what you're looking at, or one of the things you could look at, is how symmetrical the boat is and where that center line is and what the shape of the ship is in relation to either side. Of course, obviously not back to what it should be, because nobody knows what it really should be in this particular story. Another shot of the other side. You're always looking at kind of what differences there are side to side. In this case, you've got a a couple of portholes, which would be the engine exhaust, which would only exist on one side of the boat. And so if you're comparing side to side, anomalies like that tend to show up, and it's good to understand what you're looking at. Here again, you can see the cross braces that I mentioned before. We actually had an instance at some point where one of these came a little bit loose, and it was kind of confusing for me to understand why. And upon talking to some of the technical guys that run the dry dock, they said, well, for sure, the shape of the dry dock is going to change if you've got, temperature changes or the sun hits it, because it was sitting in, Lake Union water, which is basically ocean temperature, and now we've raised it up. It's drying out. It's getting kind of warmer air at it, and the U shape of the dry dock has a tendency of changing. So again, the race of time to get all the scans done as quickly as possible in order to maintain the best accuracy as possible was on. Fortunately, we kind of had a not so warm day. It was cloudy, overcast, threatening rain. I think I actually used the Zodiac as an umbrella a couple of times to take a bunch of the scans, but we were quite fortunate with how everything worked out. But it did take a little bit of time. We kind of kept on scanning through into the night. The primary focus was the bottom of the hull, and that was done in probably about 20 scans. The secondary focus was mapping out the top deck. And so here we've got, we're standing on top of the dry dock, and so we would have carted the equipment, which is pretty easy when it's so small, up that ladder from the bottom all the way up to the top and scanned along the top of the dry dock, capturing the side of the Zodiac. And here's another view of the data. You can see all the while we're capturing in those scans the spheres that we put up to relate each of the scans together and relating from side to side of the Zodiac. We also did some scans on the deck itself. Again, these help relate side to side and top deck and map out the top deck. In this particular image, you can also see that we're starting to capture information to the interior of the boat. And so we had a little bit of extra time after these scans were done where we did a series of scans on the inside to map out and document what the interior of the boat looks like. And of course, you want ideally the interior in relation to the exterior. So scans like these which link together these common areas, such as a couple of points of access into the hull, are really quite important. So why we're doing this is really so that we can preserve the schooner Zodiac and if repairs are ever needed to be done, and understanding more about how she sails and why. But after all that data was collected, there's an important step that needs to go through. The Faro Focus is really easy, like I said, that just writes data to a memory card. And so afterwards you take that memory card, go back to a computer, plug it in, and all those individual scans would get registered together. We use the Faro Scene software, which extracts out those sphere points that were set up during the scanning, and then uses those common points to fit the data together. And in some cases, if those spheres weren't available, you can actually fit kind of cloud to cloud together as well. And that's how we did some of the waterline shots that you saw earlier. But I highly encourage people that are interested in sailing tall ships to check out the schooner Zodiac and enjoy the amazing opportunity that's out there. Christian, maybe you can take it from here and explain how the data got processed further.
Yeah, so after we've done all the scans and we have registered them within the Faro software, we ended up with one giant point cloud. And before I'll talk a little bit more about this, I want to give a little bit of a background to you. Is that, I was a complete rookie on doing this. Yes, I have an engineering degree and I spent a lot of time with CAD software like 20 years ago. But, I was looking for software which could do this kind of reverse engineering job, and I ran into Geomagic Design X and was a complete rookie. And I basically started reading, some of the help topics, and I actually looked at a lot of YouTube videos to see how people do stuff, and then I got started. The amazing thing to me was that I was actually able to go do most of this with almost no help. I mean, there was a couple of times where I had to ask for help, get some tips, but most of the stuff I was actually able to do by myself. So in any case, what you see here is the Zodiac, the point cloud inside Geomagic Design X, and you can basically, move this around. And let me go show you also the other side of it. What I've done here is I've clipped the view, and you can now actually go see the interior of the boat as well. Now, this is all a little bit fuzzy, but when you go in more detail, you can actually go start making out individual features and actually really re-engineer the entire boat, every single surface. You see a little chair down here. These are the bunks in the back saloon. In any case, let me go turn the clipping view off since we don't need this anymore. So now you basically have the full boat as a point cloud. Now, the first step is with the point cloud is that you need to go, clean it up. And so clean up the data. You see there's a bunch of stuff hanging out down here. I also want to show you the supports which were holding the boat in the dry dock. Well, we scanned them, and if you go see down here, when you zoom in here, you see this is one of the supports. And of course, that's not part of the data. We need to go get rid of it. So what you do here is what I done is I edited the point cloud and just deleted all the points which are related to this. Now, as a result of that, you now actually have a hole inside of the point cloud at that area of the hull. Okay? And we'll get to that part back later. So now, after you've cleaned up the point cloud, you got rid of some of this data which you don't need, the next step, what you do is you turn this into a mesh. And once you turn the point cloud into a mesh, then this is what you're going to see. And let me go turn the point cloud off so you just see the mesh data. So now here what you see is just the mesh. And let me go turn the regions off too. So this is just now basically triangles, a lot of them. And if you go zoom in, you'll notice, this now becomes, these are all little triangle surfaces around here. But one of the things I've learned initially is the first thing for any of these types of things you need to do is what you have to do is you have to align the point clouds to proper coordinate system. And so what I've done is I've basically aligned the point cloud and the mesh data to the center line, the water planes, and sections. So let me go rotate that so you can go see this. So we have the center plane, which is the most important one, and it turned out that part was actually very tricky to do because this boat is 90 years old and it warped and it hogged and it changed shape. So actually finding the center plane was actually not a simple process. I actually had to go identify a whole different points inside the scan, and then use a software to approximate a plane through it. Once the plane was there, I went back and verified it with various points on the boat if this is so correct. So it took me actually quite a while to get the center plane right. Now, once you have the center plane, the next one was the water plane, and on that one, I approximated as well. I just have to have the height, and I know that this piece here in the front from the bowsprit is just above the water line usually when you run the boat, and then in the back there's a similar indication for me to do this. Now the water plane, of course, when the boat gets loaded, changes, of course, And it's the same when you put a lot of fuel on it, a lot of people, even when the people move from left to right, that plane actually changes in the water all the time. But so for the modeling, you just needed it as a reference. And then the last one I created is a section plane, and I put that section plane right at the front of the boat, and later we will use this to use multiple copies of that to create section lines. But I'm jumping ahead of myself. So let's go back to the mesh. And so now how do you work this mesh? Well, the first thing I did is I actually had to split the mesh into smaller pieces because the set of data was just too much, and then things start slowing down. So you don't want to work with too much data. And so the ones you want to work on, so you go break this down. So here in this case, let me show what I done is I'm actually have a mesh just for the port hull. And when you now go zoom in, you will notice here's a big giant hole. Well, and here's two other small ones. This hole I did not close because it's part of the engine exhaust, which you saw in the picture earlier from Ross. But what I did on this mesh is I did already fill all the holes which were down here from the supports. And the software has, mesh editing tools which are really simple. So you use one says fill hole, so you select it, and the software will fill that hole with the mesh. In any case, so cleaning up the mesh is the next step of this process, and this takes some time. However, once you're done with cleaning the mesh, then the next step is to actually start identifying regions on the mesh. Okay, and that's another very important feature in the software, which basically now colors mesh areas of similar curvature. Okay, and in this case, you can also manipulate these regions by selecting them and combining them. And so what I've done after this region process was done, I actually had to go back in and combine a whole bunch of these regions so that they are part of one. So for example, here is one I forgot to add. So like this little orange section down here should actually be part of the green one. However, in this case, it's really not that important. Now, when you look at it, you will notice that there's actually two distinct regions. One is the surface of the hull, which is this one, and then down here, this other color one is actually it's a plane surface, which is the keel. And if you remember the picture from the hull, that area is actually, a very straight line. It's not a free-form surface, just like the hull. So what I decided to do is I decided to generate actually two separate surfaces and then combine them, and you'll see this. You see this a little bit later. So now the next step in this process is to actually put the surfaces on it, and therefore Geomagic Design X has some incredibly powerful features which also are very easy to use. One of the features is called Mesh Fit. And so in this case, you just select the region which you want to put a surface on. And there's a whole bunch of parameters you can define, how smooth it is, what's the allowable deviation, etc. So you can go play with these quite a bit to get to a result. However, the next step is it will now try to approximate a surface, a B-spline, a full mathematically defined surface right on top of this green mesh area. Now this is a fairly complex operation and usually takes a little bit of time. And so here is the first step. And what you've noticed is that it will actually extend the surface to beyond the area of the mesh which we selected. Okay. Now, when you go rotate this now, you go see that the hull surface of the boat is actually you know, very well represented with this surface approximation, except when it reaches the corners, then it goes a little wild. But at this point, you know, I'm not really concerned about it, because what you want to do with this process, I have already a surface created, so I'm going to go disregard that because it takes too much time, and I'm just going to show you the surface which was created. So now there were two surfaces created. The one is along the plane, the other one is along the hull, and you now see there's a whole bunch of stuff sticking over. And what you do later in this process, you actually then start trimming these surfaces by themselves. And for that purpose, now since this process will take a little bit too long, I'm going to go switch models to another model where I have done this already. And so on this one, I can show you all these surfaces. And so the first one you see here is the deck surface, okay? And the deck surface is basically based on this red mesh area here. So I use this red mesh area on the deck surface so the software generates, you know, a surface. And as you can see, that surface has a curvature from front to back, but it also has a curvature from the center to the outside. And that's, of course, so that when there's water coming over the bow, the water will basically run off to the side of the hull. So anyway, so now you have this surface. So now the next surface you already saw would be the port hull surface, correct? So you can now see how these surfaces, you know, intersect. And as I now turn on, there's another surface I've added, which is the railing, which is basically on top of here, which is kind of the railing. And this is where the hull surface on the outside will end. So let me go add that surface. So now you have that one. And then there's a surface which I call the transom, which is in the back, which, you know, it's basically the back part of the boat. Let me go rotate there so you can see that. So right here you see the transom surface right here. Again, all of these surfaces are extended over the mesh area which they were trying to model. And so once I'm now done with this here, hang on, I'm going to go. So now we go zoom back in a little bit. So now I can go turn on the starboard hull as well. And now you have most of the surfaces needed for actually building a full hull model, okay? Now, another interesting thing about Geomagic Design Access is that it's really a CAD system which keeps track of every single step you've done. So you can roll back, forwards, and forward. And in this case, what you can see here, you know, here's all these trim operations, which will now trim all of these intersecting surfaces and cut off the excess off it, okay? And for the demo, I basically tried to accelerate this a little bit. So what I was going to do is I'm just going to roll forward to here. I've already done that before, and the software will just redo it. It will probably take a minute or so for all these trim operations to be applied, but as a result of that, you should then see, you know, a full surface model of the hull and the deck of the boat, and which has now finished. And when I now go turn off the mesh, you basically have a CAD model of a boat. Okay, so now this is basically the hull of the Zodiac, you know, as it exists today, but in a CAD model. Okay, so now the next step you will work on is that you now go start detailing a bunch of more items to it. Okay, so let me go turn on the point cloud again. So at this point now, the next step what I've done is I've added actually a couple of solid bodies. For example, the mast. Well, the mast with cylinders is pretty simple. I mean, they're not exactly cylinders, but for our purposes, it was close enough. But so now I generated a bunch of solid bodies as well. And when I go turn off the mesh, you can now see the boat, the CAD model, slowly coming together. So here we have the bowsprit. Here we have the the deck rail. This is a solid actually. And so as I was going along, I was able to model a lot of the features of the boat. Now, what we set out initially to do was not to generate a full solid model of the boat. Initially, the whole purpose, what we were setting out to do, is to actually create lines for the boat, okay? And so this is where, again, a bunch of the features from Geomagic Design X come in, which are really, really powerful. What I've done is I was able to use our planes to generate section lines, water lines, and butt lines of the boat. And basically, the process is you tell the software, okay, I want every 3 feet another section plane, and then I want you to slice the hull and generate a curve along the surfaces, okay? And this process, the result of this process is now this, okay? So now what you see is now you actually have curves of the boat, and these curves all follow precisely the surfaces we generated. So let me go turn off the surfaces and the solids. And now you just see the line drawings, in a three-dimensional way of the boat. So now we're really close to what we set out, what we initially wanted to do. So let me go align this guy a little bit. Here's also now one thing what we've learned in this process of generating these lines. Now, when you look at boat lines, especially these butt lines, these ones here, when the boat is symmetrical, the butt lines on the left and the right side of the boat will be identical and lay on top of each other. Well, here in our case, they're not. Okay? It turns out that the hull of the Zodiac is actually indented on port up to 3 inches to the center line. And the butt line right here will show you this. So this butt line tells you that the port and starboard hull are not symmetrical in this area, okay? And that is also now explaining some of the different sailing performance we have on a port or starboard tack. Because when the boat heels, so let me go see if I can show this quickly. Hang on. Here you go. So let me go rotate this. So when the boat is now sailing and it starts heeling, the boat will tilt. Let me see if I can rotate it in the way I want it. It doesn't let me. So the boat basically tilts this way, and then, the water is basically over here. And so with this now, when we looked at this data, it basically explained to us why the boat behaves slightly different on a port and starboard tack, because the hull on port is a little bit more indented, and when the boat heels to port, the surface of the hull is just different, okay? Anyway, so at this point, what we've done, to create the actual line drawings, I exported this data in one of the common, CAD formats, and I loaded it into another software from 3D Systems, which is the design product. It's not the Design X, it's a design product, which is basically a 3D CAD program, but that allows you also to generate line drawings. And the result of this process, creating these line drawings now was actually very quick. It only took a couple of hours to load the data into this other software and then generate and project these line drawings. And this is what we set out to do for the Zodiac. And we now have actually fairly accurate line drawings. The only difference with these line drawings is they are line drawings which are not symmetrical. You know, line drawings for boats today, when you see them, they are all represent a symmetrical hull. Well, in our case, the hull is not symmetrical, and so the line drawings, you know, look a little bit different, in this particular here, the butt lines, which I've already explained. So we set out to generate hull and line drawings for the boat, and we were able to do a 3D scan and use the Geomagic Design X software to manipulate the point clouds, generate a mesh, clean up the mesh, and start generating surfaces across the mesh, and then ultimately use these CAD surfaces to generate section lines, butt lines, and water lines, which are the basis for these line drawings. So now, once we were done with this project, we of course also realized that, man, we actually have a lot more now than what we set out to, because having a full 3D CAD model of the boat will let us do a lot of other things which are on the list, on the maintenance list for the next few years. One of the things we want to do is we want to most likely update our stability analysis. So the Coast Guard requires for every vessel carrying passengers to a full stability analysis to be done, and that has been documented, and there's actually a little booklet on the boat which contains this entire analysis of the boat. That stability analysis then also determines what type of sails you can run and how many passengers you can carry, et cetera, et cetera. Now, having a full CAD model of the boat now, we can actually do a much more accurate stability analysis than was possible before. And so we hope that we can update that stability analysis for two purposes. One is so we can maybe carry a few more passengers, because of course the boat has to earn revenue, and carrying more passengers, you know, is necessary. The other thing is the captain himself, he's a big tall ship fanatic in a way, and he really wants to have top sails on the boat. And the top sails are the ones which are right on the top between the two you know, masts. And today we don't have any top sails for the boat, but we now have the data to actually be able to create them, because we now have accurate measurements on the rigging as well, not only the hull. You know, so that was another benefit. And now the third benefit which came out of it, we're also an educational vessel. We take a lot of high school kids, and we teach them about navigation. We teach them about boats. And so one of the next things I'm planning on doing is to actually 3D print the boat, because now I do have the data to be able to do that. So once I have a 3D printed version of this boat, you know, you can use this for kids and for teaching purposes as well. So as you can see, there was a lot of good things which came out of this initial idea of getting line drawings, but we ended up with a much more valuable thing, which hopefully will help us, you know, keep this boat afloat and have a lot more people enjoy it in the near future. So at this point, I think I'm pretty much at the end of my part, and I think we should be opening up to questions. Hello?
Yeah, sorry about that. So yes, we're at that point now. If you have any questions, please feel free to throw them into the questions box so that we can answer them at a rate as best we can as they come in. So Christian, I might have a couple questions here for you. Is this something? Are there other boats? There are other things that you're looking at down the line now that you've gone through this process that maybe you want to continue, or you'll look at maybe for other vessels, or at least maybe to consult with people with other vessels now that you've found that you've had such great success with this process?
Absolutely. It's actually already happening. I was just down at the Tall Ship Conference about a week ago, where, you know, all the tall ship owners in the United States get together, and there was a whole bunch of guys who already were interested in learning more about it, and there was one boat in particular who basically ask, oh man, we have the same problem, we need to go get this done. So I'm waiting for them, to come back to me, and then we'll see, if there's a few more of these vessels where we can do this. Now, I've found on the web a bunch of maybe 2 or 3 other vessels, older ones, which were scanned, but I have never seen these scans be turned into actual full CAD models.
Sure.
So we'll have to see where these are.
Sure. Hey, Ross, there's a question here about what were the total number of scans that were done on the boat, throughout the entire process, if you could remember,
Right. Yeah. There was 19 done inside, 34 done outside, and then 3 at the dock to establish waterline, so a total of 55 scans.
Okay. And of all those scans, what was the most challenging part of the scanning process? Like, what was your biggest challenge throughout the entire ordeal?
Well, there was a few. One was the weather, as I already alluded to. But that's not within the control. But from a scanning and a technical perspective, really the challenging part is linking all the data together so that you can relate one area to the next area. In the dry dock itself, around the bottom of the hull, that's not too bad. The spheres that you saw work really quite well. It's a fantastic way, and using the FaroScene software to automatically recognize those spheres and register stuff works great. But to link the inside of the ship to the outside, you can't look through the walls. So you've got to find the few openings to kind of get a ray of light, or a laser in this case, in and out to try to match those common elements. And so there was kind of some tricky spots to put the scanner. We actually even scanned underneath the subfloor of the Zodiac as well to try to map out the structural integrity of it too. And so some of that was a really tight space requirement, and the FaroFocus being so small and portable, it fit in there fairly well, and we got the best data that we could possibly hope for.
Awesome. And what was the time set to each scan?
I believe I ran it on quarter resolution of what the FaroFocus was possible of doing, and I believe that takes about every 15 minutes or so is a scan. There's a sequence there where it collects the 3D data, and then it takes the photos to kind of add the color back to the data set, and so I believe it's roughly around 15 minutes.
So, and one more question about scanning, then I have a few coming up here about the software. Are there any other environmental concerns other than rain for scanning when you're in someplace like that you need to consider before you start setting up and capturing data?
It's fairly flexible. It's got a fairly wide temperature range. I've done some scanning with it myself, and kind of into the freezing temperatures. It still works quite well. I guess one factor would probably be wind. In terms of, you've got, in this case, the spheres mounted. You don't want them moving on you. So really windy environment might be a little problematic for kind of the objects that you're trying to scan. But other than that, I can't think of anything, and maybe Zach from Faro may be able to pipe up if there's some other consideration.
I remember one issue we've discussed with the dry dock itself, correct, and the sunlight. One thing is we've learned. Someone told us is that when the dry dock warms up, there can be up to a 2-inch delta in the width of the actual walls. Okay. And that happens when one side gets hit by sunlight and it heats up, and the other side doesn't. So that can really mess up your scan data, because so that's what Ross alluded to earlier too as well. Is you've got to be really careful that you are not running into temperature or wind or other environmental driven changes or movement of your reference spheres in particular.
Right, and I think just to kind of close off a couple of those questions on it, it's a two-parter here, which is, didn't the water surface on the boat create a problem to scan, and what were the total number of spheres used to scan the total boat?
Right. So the water surface, like just kind of a wet surface, didn't seem to have a real impact on the data set. So that was nice to see. The total number of spheres, I had 12 available to me in total, but what I did is I kind of leapfrogged them ahead. So for example, if I started at the rear of the boat, I set up my spheres, maybe from the rear to maybe about 2/3 along the length. And as I progressed from the rear moving forward, I took some from the rear and put them at the very front. And so in the data set, when it got put together, it appeared like there was more than 12.
Okay.
I don't remember how many times I kind of did that leapfrogging. It kind of was whatever made sense for the space that I was working on. But it worked out quite well.
So moving a little bit now into the software, about the software part of this. How long did it take to create the model after you brought the scans into DesignX?
Well, that's a difficult question to answer because you have to factor in that I was a complete rookie. So I had absolutely no training, I had no experience, no knowledge about the software. So I would argue that from the amount of time I spent on it, at least 60 to 70% of the time was me just learning and figuring out how to do this. Now, if I would have to do a boat like this again, I would think it would probably take me, about a week, about 40 hours. To create the surface, basically to create the exterior model. Now, not to the extent what I've showed you.
Sure. And then, how much did you have to subsample the scans to get them into DesignX? Were they pretty good to go, or did you have any subsampling that you had to do in the process?
We did some sampling. We did some data reduction before we loaded into DesignX. And then I actually did some additional resampling once I had it in DesignX. DesignX actually lets you resample, and it has an interesting feature where it says, flat surfaces remove a lot of points, curved surfaces leave a lot of points. And so that feature also helped significantly to reduce the data set. So initially when I started, I started with big sets, and things got really slow, and things were not moving at a speed, and so then I asked some questions, and that's when I learned that if you reduce the set to data to what you need, and then even further slice it into subsections as I showed, now suddenly you have a set where you can work very fast. So,
sure.
So the one number I found was that if you have about 40 million points for something to work with, that's a good size to work with. So a mesh based on 40 million points, that makes it perform. I mean, of course, it also depends on the hardware you're running.
And while we're on that subject, did you have any scans that you had trouble registering? Good usable data with all? Did you get good usable data with all 55, or were there kind of instances where you needed to kind of make some adjustments?
No, I think we had all of it was actually pretty good. The biggest struggle I had actually, is that when I was trying to register the interior of the scans, since we were not able to use any reference gears, you now have to go use reference surfaces and other geometric elements, and that requires for you to kind of have a good knowledge of the boat, because now you're looking at a bunch of points and you're under, okay, this is so aligning the interior scan was far more time-consuming than the exterior scan. The exterior scan with the reference gear, that went like a breeze. The interior one was a lot more tricky.
So, what accuracy did you achieve in registering the scan? Did you have a good? Was it a high percentage? Did you, what were we looking at there?
Yeah, I can probably answer that.
Awesome.
I'm kind of going by memory, but what I typically see, and I don't think this is any exception, spheres got registered to somewhere in the range of kind of 1 to 2 millimeters, and I think this wasn't far off that. And then the interior scans, as long as you got good overlapping data that constrains it, you should get kind of a similar order of magnitude out of that.
True. Did you rely primarily upon the sphere center alignment from Scene, or did you utilize more feature-based cloud alignment within DesignX, Christian?
For aligning the software, for aligning the point clouds, we actually used all the Faro Scene software for that.
Okay.
I did not do any point cloud alignment within DesignX.
Okay. And the software used for the data reduction?
I would say a little bit of both.
A little bit of both?
Yeah.
Okay. Okay.
Yeah.
That's kind of what I thought would be the answer there.
I mean, the one other thing to notice here is that when we were done with the scan, we had about 2 billion data points. Once we started throwing out all the shipyard stuff, and we only had about 1.5 billion data points. There was about 700 million on the outside and about 800 million on the inside, I think. But then we started reducing that down even further. So I think for the hull, ultimately, I worked with maybe 100 million, 150 million instead of the 700 million we've had scanned. So.
With the manifold, we're looking at the manifold creation here. What is manifold creation and facet creation of the point cloud data for automatic surface creation? It seems like a tricky question. Yeah, I'm trying to. What is manifold creation in? And Sean, see if maybe you can help decipher this a little bit. But what the question here is what is manifold creation and facet creation of the point cloud data for automatic surface creation?
Oh boy, that's a mouthful there.
Yeah.
I guess if you could ask the person that asked that question to clarify a little bit.
So why don't we do that? So Ranak, the person who asked this, could you give us a little clarification, since you're still online, if you could clarify that question a little bit, we could jump to another one, and then we'll come back and maybe try to answer that with a little more definition. Another question here, and this could be for Sean and or for Christian, I guess. Is it possible to export the 3D PDF with PMI dimensions?
Unfortunately, no. We cannot do. Well, yes and no. Actually, I mean, all the dimensions that come that are included in the design process are true to life. Obviously, once you kick them out, we do have a live transfer feature, and I'm not really sure that Christian talked too much about this, but we can take your entire parametric history tree and dump it step by step into the CAD package of your choice. So we support SolidWorks and Creo and NX, those types of software. So most of the major parametric modeling softwares out there will be able to have your model rebuilt step by step. So all of the dimensions that come into it, you know, if you do dimensioning live in the sketching or whatever, in your extrudes, your modeling operations, they all do come in true to form. So in terms of actual PMI, you cannot do that.
Right.
Yeah.
Okay. So Christian, what are the plans for modeling the interior?
Every time I get started on it, I get a headache. Because it's far more complex, the interior, than the exterior, which is funny because the interior surfaces are a lot more straight, correct? They are plane surfaces, they're cylinders, they're not free-form surfaces like on the hull. But the problem is the boat was actually, there was a lot of gear and a lot of tools and stuff everywhere, and that, of course, got all picked up in the scan, and I have to clean that stuff out first. So I'm going to have to spend a lot of time cleaning up the mesh data, which basically means I virtually clean up the mess we had on the boat. And once I have done that, then I can start, identifying the right surfaces. I mean, one of the big things I want to do is I want to go get the floors done, so you know where the floors are, because of course even the floors on that boat are not straight. They are actually curved surfaces. And then I want to get the basic walls of the different compartments. And then once I have that, then I'll start making my way down into the engine room and try to work on the engine and the drive shaft. which are other crucial elements. But I will. I mean, as I have time, I'm gonna go keep further detailing.
And the last question here, and for those whose questions we haven't answered to a couple, I think when we're looking for some more clarification on, you can feel free to email us at inquiry@geomagic.com. It'll also be in the follow-up email coming shortly, and we'll make sure to try to get those questions answered for you to the best of our abilities. Last question would be, how can you align the two different scan data sets in DesignX?
That's not. I mean, that's a. Like I said, I did not do any scan data alignment in DesignX, so that's something I think Sean would have to answer.
Yeah, Sean, could you talk a little bit about that?
Sure. There is plenty of registration options in DesignX. It's actually got a lot of stuff built in. The scan processing tools are incredibly robust in there. We have kind of a manual. Basically, the process is to align them roughly either by auto feature recognition or doing it manually by pick points method. And then we have a global and fine registration that essentially just tries to minimize deviation between all the points in overlapping regions. So the takeaway here is, you know, especially in DesignX, we do also, I'll back up a little bit, we also do have spherical target registration, automatic. It basically automatically scans and finds targets of a specified radius. But there are, plenty of other options in there that does all of this pretty much automatically. You don't really, it's pretty much hands off.
Right. Okay. Well, listen, I want to thank everybody for their questions and for attending today's webinar. You can learn more about the FaroFocus 3D on Faro.com. You can also learn more about Geomagic DesignX at geomagic.com. A link will be sent to everyone who registered tomorrow with a little bit more information about this project, a recording of the webinar, as well as a link to a case study on 3dsystems.com that talks a little bit more in detail about this process as well. I want to thank Christian and Ross for attending today and getting up early to put this on for you all. I'd like to thank Zach as well from Faro for attending, and of course Sean Parker, our product specialist here for Geomagic.
And if any of you ever want to go sailing, you now know where to go.
That's right.
Zodiac.com.
That's right. That's right. Not only that, but you've also got a great boat when you're there to go to vote in the future. So, again, thank you, everybody, and enjoy the rest of your day.